today we're focusing mostly on the zeros. And we know already, we've had that factor theorem that said if something was a factor, that meant it divided evenly, right? And we got 0. So if I tell you the first factor, then you can divide your polynomial, and then we can try to use our factoring techniques to break things down from there. So first we're just going to check if things are a factor. So if I want to know if x minus 1 is a factor of this, there's two options. Can you tell me one way to decide if it's a factor? You can do synthetic division. What would you put in the box? 1. And what would we need to get for a remainder? So if we get a 0, it's a factor. If we don't, it's not a factor. That's the first option. What's the other option? What would you plug in? So we would plug in 1, because remember the remainder theorem in that last section, it said that if you plug in your k, f of k would give you the remainder when you divide it. So we can do either option. I'll do A and B 2 different ways just to show you 2 options. So synthetic division, you do your 1. So 2 comes down, multiply the 2, let's add the 1. 1 times 1 is 1, plus 2 is 3, and 0. So I see the remainder is 0, so it is a factor. The second option is find the k value. So what would that be? And you plug that into the equation. So we find f of -2. So that would be 2 times -2 cubed minus -2 squared. That's 2 times -2 minus 3. So we get -27. So that's the remainder. So this one would not be a factor because it didn't divide evenly. So using whichever method, whichever one you like, then I want you to decide if x minus 2 is a factor of this. So it is not a factor. All right. Now, eventually we are going to factor polynomials without me giving you any starting point, but today I'm going to give you the first 0. So I want this to be completely factored, given that 5 is a 0. Before today, your only option for factoring something like this would have been grouping, because we had 4 terms, but if you try grouping, is it going to work here? No, on the first one you could take out an x squared, but there's nothing you could do to make them match. So grouping would fail. However, if I give you the first 0, we are going to start synthetic division with that 0. So my 5 goes here, my coefficients. Down. And I know this remainder should be 0 because I told you it would be. So if you get anything else, you've made a mistake. So there's my remainder, my constant x and x squared. So I've turned this into 6x squared minus 7x minus 3. If I want this totally factored, how could you factor from here? Slip and slide?
Yeah,
18. So that factors into x minus 9, x plus 2, divide by 6. So 9 over 6 is 3 over 2. 2 over 6 is 1 over 3. Right. So my final factored form good indicator, this was originally x to the third, so that's degree 3. If I multiply these, what am I going to get? We hope so, yeah. But if right now with only those two, I would only get an x squared. So what else do I need down here so I would get an x cubed? We need another x. But what was our other 0? We were given that 5 was a 0. So that meant what was the factor? When you put an x with it, would have been x plus 5 or x minus 5? So the final factored form would be these 3 pieces. As a general rule of thumb, your degree tells you how many parentheses you need to have. So it's degree 3, so I expect 3 parentheses. Now that's not a hard and fast rule because I could have a square on one of them or something. But that's a big clue for me. You will always have to add in that first one. So if I give you the first 0, we have to put the factor in there. So a 0 is just a number. When I say the factor, that has the x with it. And if we multiplied this all back out, we would get the problem that we started with. Alright. Is that okay? Let's do an ugly one. So this one's kind of nasty looking because of all the i's. But I gave you k, I gave you that first 0, so 1 plus I, right here. My coefficients are 2, 3 minus 2i, negative 8 minus 5i, and 3 plus 3i. Alright, so 2 comes down. When you multiply these, you distribute the 2. So 2 times 1 is 2, plus 2 times I is 2i. When we add like terms, you just get a 5. So multiply. 5 times 1 is 5. 5 times I is 5i. 5i's drop, and we get negative 3. Negative 3 times 1 is negative 3. Negative 3 times I is negative 3i. When we add, we get 0, which we knew we should because I told you it was a 0. So then we have 2x squared plus 5x minus 3. We do our slip and slide. Gives us x minus 3, x minus 2, divide by 2. X minus 3 times x minus 1. But for my factored form,
wait, wouldn't it be x plus 6, x minus 1?
yep. I did multiply to a positive 6, didn't I? Just making sure you're paying attention. Alright, how about that? X minus or plus 6 and minus 1 divided by 2. So we get x plus 3 and 2x minus 1. Alright, so the factored form. Original problem had an x cubed, so I really expect 3 parentheses. So we have the x plus 3. We have the 2x minus 1. I need one more. This is the one that kind of gets people. You always do the opposite. So right here our 0 was 5, so we did x minus 5. Here my 0 is 1 plus I, so I need to do x minus the 1 plus I. So what would I have to do with that negative? So it's x minus 1 minus I. Okay. Is that okay? Let's do, I'm going to do one with you and then I'm going to have you guys try one on your own. So, I gave you the first 0. What do we do? 1, negative 1, negative 4, negative 6. Okay. At this point, we need to do the x squared plus 2x plus 2. And normally, what are we able to do? Factor it. But, is there anything that multiplies to 2 and adds to 2? No. My directions were also a little bit different on this one. I didn't ask you for the final factored form. I asked you to find the remaining zeros. So it's an x cubed, so I should have 3 zeros. I gave you the first one, we have to find the last 2. I'm asking you what makes this equal 0. So if we can't factor it, what could we do? Set it equal to 0. And how can we solve it? Think about like our quadratics test. When things didn't factor, what other thing?
Formula.
Yeah, quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. What's the square root of negative 4? So if we divide by 2, we get negative 1 plus and minus I. So my remaining zeros are negative 1 plus and minus I. There are a lot of questions I might ask for on these. I could ask for the factored form, so that's when you have the parentheses times each other. Factored form, you have the x's. I could ask you for the remaining zeros, which doesn't include the first one that I gave you. If I asked for all the zeros, then you would have to throw the 3 in that list as well. Why don't you guys try the next one? So do just synthetic. negative 0 for the remainder. So we have x squared plus 7x plus 12. And that does factor in nicely, x plus 3, x plus 4. But the question on this one wasn't the factored form. I asked you for the remaining, so not including the one I gave you, zeros. So if x plus 3 is a factor, what would the 0 be? You just say each of those equal to 0. The last thing we're going to do is, I'd like to do just a couple examples with what we're working on tomorrow. So what to do if I don't give you the first 0 to start with. So we'll do a couple today and a lot more tomorrow to practice that. So there's this big, long theorem called the rational zeros theorem. And it tells you that in a polynomial where you have all integer coefficients, every possible rational zero, so the nice ones, the ones that can be written as a fraction. So this doesn't work for imaginary zeros or like square root of 2, things like that, just the nice zeros, are going to be of the form p over q. P is a factor of the constant, q is a factor of the leading coefficient. So when we do these, we are going to have a series of steps that I'm going to ask you to go through. On a test or quiz, I would break this down. I'd say part A, do this, part B, do this, and tell you exactly what I need you to find. So in order to get the rational zeros, we are going to start by getting the p and the q values. P comes from the constant. So p is everything that goes into negative 6 evenly. So how could I get negative 6? 1 and negative 6, negative 3 and 2, negative 1, positive 6, positive 3, negative 2, right? So we can do any combination of positives and negatives. So we're going to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. You can put those in any order. I always put them in numerical, but you can put them in the order you think of them. They will always have positive and negative, because it doesn't matter if my p value is a positive or negative, it would divide evenly either way. So all of these, every one of them always gets plus and minus. Q. Q comes from the leading coefficient. So what's everything that divides 2 evenly? Right, so I'm just going to put plus or minus 1, plus or minus 2. Then I'm going to ask you for the possible zeros. So possible zeros, that's everything in the form p over q. Again, every one of these gets a plus and a minus because we could do any combination, top positive, bottom negative, and vice versa. So each p over each q. So 1 over 1, plus or minus 1. 1 over 2, so plus or minus 1 half. 2 over 1, so plus or minus 2. 2 over 2 is 1. We already have that, so I'm not going to list it again. 3 over 1, plus or minus 3 over 2. 6 over 1, plus or minus 6. And 6 over 2 is plus or minus 3, but I already have it. So essentially, right here, I have a list of basically 12 numbers that could be a 0 of this function. So 12 numbers that when I plug them in might make this function equal 0. And we need to find one that works, and then that would be the equivalent of me giving you that first 0. So there are options for that. We could just start plugging those in, couldn't we? We could grab a calculator and plug them in. So if you put in a 1, 2 times 1 cubed, plus 11 times 1 squared, minus 7 times 1, minus 6. What do we get? 0. That was a lucky first number to try. In general, if I'm picking numbers to plug in, I try the whole numbers or the integers first. Fractions are kind of a last resort just because it's a little bit, the synthetic is a little bit different and how we interpret the final answers is slightly different. So it's easier if you don't have a fraction, but not required. However, you found one that works, and we know it works because we plug it in, it makes it equal 0. So now you have that first 0, and we know once we have the first 0, we do synthetic division. So we're going to do synthetic division with that 1. And then we have our quadratic, so we can do our slip and slide. Multiply 12 and add 13. Over 1. Add by 2. Alright. So we get to this point. Now I asked for 2 things. I wanted the factored form, and I asked for the zeros. So the factored form, we have x plus 6, we have 2x plus 1. What else do we have to have? X minus 1, because that was our starting point. All right, the zeros. How many zeros should we have? 3. How do we get them? So x plus 6 equals 0 gives me negative 6. 2x plus 1 equals 0. We get negative 1/2. X minus 1 equals 0, we get positive 1. Okay, look back at your list of possible zeros. Were all of those numbers on our list? Yeah, so we could have even found them all just by plugging in all 12 of those numbers until we got to 3 that worked. But everything there was on my possible list. All right. Questions on that one? Let's try one more for today, and then I'll let you guys start your homework, and we'll do some more tomorrow. All right, so possible zeros. I want P, Q, and the possible. So what are my P values?
Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8.
Everything that goes into 8. What are the Q values?
Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15.
So possible. P over Q. So 1 over 1 is 1. 1 over 3. 1 over 5. 1 over 15. 2 over 1 is 2. 2 over 3. 2 over 5. 2 over 15. 4 over 1 is 4. 4 over 3. 4 over 5. 4 over 15. Okay, if we plug in an 8 over 1 is 8. 8 over 3. 8 over 5. 8 over 15. So this one was not nearly as nice. we have a much longer list of options here. 32 different options for what could work. All right, we need to find one that does. If it were me, I would start with like our integer values. And if we put in a positive 1, that's not going to work. If you put in -1, -15, plus 61, -2, -8, that doesn't work. Plus or minus 1. You guys try. Is a positive 2 going to work? Or a -2? Kind of divvy it up. Everybody check. I want you to check -4. Grab a calculator if you need to. So it looks like if you plug in positives, you're going to get really big numbers out. So I'm going to guess it's probably a negative. Let's see. Tyler's checking -4. Somebody could check -8.
I'm trying negative.
We can go to the fractions if we have to.
Does CC equal 0, right?
Mm-hmm.
Yeah, no.
It doesn't?
So there's no option to check. Oh wait, I still don't think it does, but.
I think -4 does work. Put it in parentheses.
I'll like double check that.
15 All right, so we have our first one. Comes down, let's multiply -60, so on. 15x squared plus x minus 2. Slip and slide. So x plus 6, x minus 5. 15. 5x plus 2, and 3x minus 1. So the factored form, f of x equals, we have 5x plus 2, 3x minus 1, and if -4 worked, what was the factor? So the zeros, if we set each of those equal to 0, we get -2/5, +1/3, and -4. And were all of those on our original list? Alright, so that's our stopping point for today. And I think I put on there your assignment, right? That next slide.